focus on water-soluble fertilizers. Actually, that day there was some organic matter. But yes, this is a kind of farm-made compost with animal manure, everything that was around. That was being mixed on a proportion 90-10 with polysulfate, manually mixed and applied with this kind of system, just like if it was a soil amendment incorporated in the soil. In this case, it's almond trees. So it would be much better, and it wouldn't need this machinery. We would have a kind of, like biosolids are working on, kind of pellet that would help using any kind of machine or even hand spreading on. And this is another one I wanted just to mention before we go into water solubles, is the direct application of this polysulfate standard. In France, there is a company you can see in Facebook, it's MD Agri. They made out of it a business, and they are doing a direct application of almost 3,000 tons of polysulfate standard, actually impacting 3,000 hectares, because the application rates they are doing is around 1 up to 2 tons of polysulfate standard per hectare. And this is mainly for vegetables in places where they are going to do sugar beet or kind of field vegetables, broccolis, cabbage. All this is brassicas especially, and also for organic farming. They do this kind of in between fertilization amendment, because rates are very, very high. So let's go to, this was something you would like to mention about polysulfate, something still.
Yes. It looks like as if there's a lot of dust.
Yes, it is. Actually, the dust is more or less controlled. They are applying dust, actually. They are applying polysulfate less than 1 millimeter size. So it's the polysulfate standard that is used for making PK+, the PKs with polysulfate inside, for making other materials, mixing with organic matters, or also for doing granules of itself, of polysulfate granulated. In some places it's polysulfate premium. In Spain we have, it's granulated 80% polysulfate, 20% kieserite, and it's end up with 10% potassium and a little bit of more magnesium. And it's a granule which is quite hygroscopic. As soon as you apply it and you have some mist in the morning, the granules simply disappear on the soil. And this one it's a specific product range that has been developed in Spain for organic farming. You may see it's Flecotec. There are several products, these organic matters that I was showing before, which are based on acids or amino acids. And these Flecotec polysulfate granulated are part of a product range for organic farming. You may see in social media, we may communicate about it, especially for organic farming. Yeah, so if you see Flecotec, I said it's product range for organic farming, and it includes some products containing polysulfate. Then it's the same that also, maybe I know in Bulgaria, someone was referring to the Fertiberia, which is a producer in Spain, you probably know. They also use polysulfate in their NPKs. And they created a product range which is sulfactive, which have these secondary macronutrients from polysulfate, together with their nitrogen and phosphorus. So they are working on that direction and creating these. So this product, you may see sulfactive beyond Spain sometimes. Actually, it contains polysulfate, but it's Fertiberia's own brand. So it's not as clear as when it's a product from ICL that it contains polysulfate. Actually, there was a problem because they said in the label contiene polysulfatos, which was not a brand name. And some of the companies start claiming, because they were using lignosulfonates, that their products were also containing polysulfatos, whatever it is, because so there was this silly story, but it's about using wrongly a brand may create some problems afterwards. That you feel you find another company developing a product that overlaps, and that it's maybe using similar wording. So that well, it's also
it's okay for here. We don't have this confusion. It's
We
a
don't.
Spanish problem, so okay.
you know, but it's a success story. It shows that.
Yeah, it's okay.
But well, coming to water-soluble fertilizers and the uniqueness of ICL, it's precacid and all the product ranges with precacid inside, which are aiming to acidify the solution or the irrigation solution that we are applying. And actually, acidifying the solution is not only bringing down the pH, but it's also impacting nutrient availability. We will see for phosphorus case. It's also affecting nutrient uptake by the root. About this statement, I don't know the basis for the decreased nitrogen losses. I know about this one, the increased water infiltration. It came from a trial we did in California, but probably it happens with other products, that when you acidify the solution, actually you improve water infiltration. So this is, I know, general statements for what happens when we acidify. And there is this nutrient availability in case of phosphorus. You know, there is the how you say in English, sorry, monohydrogen phosphate, dihydrogen phosphate forms that they are more or less available in the soil solution as the pH moves. So when we have actually plant uptakes dehydrate or dihydrogen phosphate and monohydrogen phosphate, so these two, and we can see that these two converge into the 7.2. It's indicated the maximum for both. But these are the two anions that plants actually uptake. So that's the reason for aiming to a pH of 7 or slightly below 7 from the point of view of nutrient availability for the plant. This probably you know maybe better than me, those who work in the end. The idea is that we are aiming for a pH in the solution for the phosphate availability mainly, but also micronutrients and others are affected. And which are the sources that we can use? Well, we put next side by side, because actually pec acid is like a phosphoric acid. However, it has phosphorus and potassium and many advantages that we will go through, but it will be one next to the other in terms of nutrients and also acidifying. Nitric acid, which as a small farmer, and usually happen, is a product very dangerous, but very effective as well. It also creates problems in storing it when we have big containers. So it has, but it's very acidifying. You know, it's the reference when we talk about acidification. Many times we refer to how much nitric acid we need to use. Sulfuric acid, I'm not familiar with it, using it in fertigation. I don't know if it's used here. And hydrochloric acid, which is normally not, I guess, not used in Greece, as it is not rarely, at least from the fertigation point of view. Maybe used as a raw material for liquid fertilizers or others. So coming into pec acid, the composition, yes, it's a balance of 60 P2O5 and 20 K2O. So yeah, it's interesting, and it's a crystal, a single crystal, water soluble, 100%, with quite a good solubility. We will have some examples later on. Actually, this is a 1% solution, 2.2 pH in the solution. It has little chloride, sodium, because yes, it's compatible with calcium and magnesium in the solution. Yes, that's it. We are looking at the mother of a family. Yes, the same as with polysulfate. Yes, actually here it's For flood irrigation, we have had also some experiences in alfalfa in California with very good performance. If someone interested to try, we need to ask our colleague over there. He explained once, and actually I was going to include one of the slides he showed, but I don't fully understand how he did it and how he measured. So if someone wants to continue on this, please let me know for the flood irrigation. Yes, but drifts, of course, sprinklers, and then the application rate depends. But as Christos said, and I was referring to nitric acid especially, but also phosphoric acid, it's completely innocuous. There is no danger at all with this product. And it's a super acid, no, that we bring into the tank, and over there it's already kind of neutralized to a pH, a very acidic pH, but it's not in the handling process, there is no danger. So this is an advantage for small farmers at least, but also for big farms where they have people who are not always 100% focused, and of course minimizing risk. So this is in terms of carbonates. Actually, the discussion of acidification, it can be on the as neutralization of carbonates or focused on pH. We can talk about we have this pH and we want to bring it down to this other pH, or we can talk about carbonates in the irrigation solution. If we talk about carbonates, these are more or less the reference. I'm not familiar, Christos, you may know, which is the typical water content of carbonates in the irrigation areas when it comes to underground waters, but these are more or less in millimoles or in ppms. Millimoles will be also milliequivalents or ppms, as you are milligrams per liter, as you are more used. These are the reference values.
Just to add on this, that we don't want water to have zero carbonates.
There will be reference to it.
We need some amount for the quality of the product.
For the quality of the product and for the possible drop on the pH of the solution when you have zero carbonate. So actually this is coming here. Minimum, we need to maintain a 30 ppm or 0.5. This is the minimum we should maintain of carbonates. So if your irrigation water is already low in carbonates, so we need to make attention. But this is just an exercise. Carbonate-wise, we have an irrigation water with, well, this will be the case. We keep in mind that for acidifying or for neutralizing actually one equivalent or one millimole of carbonate, monohydrogen carbonate, we need actually 250 grams of pec acid. That for a cubic meter of water. I'm going to go through the calculation, but then we will go pH-wise from another way we can do it. Actually, okay, from ppm to milliequivalents, this is similar. Then we want to maintain the 0.5 milliequivalents, and we want to bring down actually 4.5 milliequivalents on per cubic meter. So that would need 1 kilogram and 25 grams of pec acid as a reference. You keep this carbonate-wise. I don't know in your case, but the tool you are using or your spreadsheet, how you calculate. We have this simple approach, which is based on pH, which is your pH and your target pH. It's based on a calculation that was put into an app. Actually, the app is called pec acid. So here, actually, this is the screen, how it looks like. We can do it, but you need to know the level of carbonate you have in your water, your pH. This comes in any analytical. Actually, it allows different units. If you have it as calcium carbonate, it's divided by 22. You can actually, no need for calculation, you can input it as calcium carbonate. and then your pH, and which is your target pH. And the calculation will tell you how much pec acid is needed in grams per liter of water to bring down the pH from 7.5 to 7, and how many carbonates will be left in the water. Okay, so these are the inputs, the carbonates, the pH on your water, two inputs, two data, your target pH-wise, and then it tells you how much pec acid per liter of water and the outcome carbonate-wise. As Spiros was saying, there is a risk of bringing down, and I was saying in the previous slide, to bring carbonates down of 0.5 is equivalent. So actually there will be a message of alert saying that actually when we are bringing down carbonates under a certain level, pH may drop drastically, and there is no buffer in the solution. So it's also just a warning to, in case your carbonates are not high enough for bringing down the pH. So, take it, make some trials with your ideas of which is your carbonate and your pH and which is your target pH in your solutions, and you can see. So for example, if you end up, can we always, that's my question, no? Could we only work with pec acid for acidification of our solution? It depends. That's the response of the agronomist always. But it depends actually how much you need to acidify. If it's a light acidification, yes, you can with 200-300 kilograms. If it's important acidification, you may need up to 1,000 kilos, which starts to be maybe too much from the fertilizer units, depending on which crop you have. And if it's a heavy acidification that you need, of course you can do it.
Water.
Yes, you need to, or pray for rainfall. But yeah, that's so another use. So this is the warning I was mentioning. This is just a case of a colleague. Okay, the pH on the water upcoming prior to the fertilization injection. Then the pH of the water already with the solution injected, and this is actually the tank with a pH of 3 with the, and here the recommendation for adding almost 17 kilos per hectare, and the injection over a period of 40 minutes of all the irrigation. Just another use that is given also in some areas. Actually, this comes from France. Sorry, it's in French actually. I think there is another slide. Yeah. But just to keep it easy, for the cleaning of the drippers and of the irrigation system, after all, it's about a 15 minutes treatment or irrigation with pec acid, depending on your actually volume of irrigation per hectare. You will need more or less. This is a calculation of which are your dripper volume and how many drippers you have per hectare, and then how much you are irrigating and how many kilos you need of pec acid per hectare in this operation. So that's it. It unblocks the drippers. It's an operation early in the season. Early in the season, it's also coming as an input of phosphorus, which matches most of the crops needs. And yeah, so that's. Now I'm looking, because over here, I think there is a data. Yeah, actually here, 67 grams per liter, and it must be much more. Because here it says 670 grams per liter. The previous number was not.
I think it's
600.
600.
600. Yes, that number when okay. So yes, it's for example using 5 kilograms of pec acid for cubic meter, and calculation of the flow rate. Well, maybe it's too much into detail, but that's it. How much pec acid we would need for a 15 minutes for a given volume. This kind of calculations. These are the product ranges containing pec acid. There is high salt missing here, which is also a family of water-soluble fertilizers containing pec acids. Well, going into the detail, there are the different, taking as example the Agrolution product range, the different formulations for the different crop growth stages or development stages. And then the two different formulations, pec acid wise, no? When there is actually we are dealing with hard waters and we need this acidification, or where we are using soft waters, the Agrolution special. So two product ranges with different effects.